1. 15 cyclists enter a race. In how many ways could they finish first, second, and third? So again, you're creating an order. It's just first, second, and third place is kind of your order here. So you could still do a permutation. There are how many to choose from? Total, there are 15 cyclists. So that would be your total. Your first number is 15. And then after your P, you need to talk about how many people you're actually going to choose. Well, you're filling in how many slots? A first, a first, second, and third place. So that means you're filling in 3 spots. So of the 15, only 3 will be chosen. So we can do that in our calculator. We can do the 15P, the 15P3. And that would get us 2730. Or you can do this using the fundamental counting principle again, and you get the same answer. Is you could do that you're filling in 3 slots, a first, second, and third place. First place is that you have 15 cyclists to choose from. Second place is that you have 14 cyclists to choose from. And then third place is you've got 13 cyclists to choose from. Now notice that the number each time goes down by 1 because once one person wins first place, they're not going to also win second. They're out of the running. They've won a place already. So then you'd be going down and you're still multiplying. And notice that if you do multiply these out, you do get a 2730, just like using the permutations. So on a test or on a My Math Lab homework, it doesn't matter whether or not you use permutations or the fundamental counting principle. Anything that can be done using the fundamental counting principle can be done using permutations. However, not everything that can be done using the fundamental counting principle can be done using permutations. Why? Permutations are weaker than the fundamental counting rule or principle. The reason being is because you can't repeat. With the fundamental counting principle or rule, it's stronger because you can repeat if you need to. So then the question becomes, why did you even teach me fundamental counting principle and permutations when I could just use fundamental counting principle? Well, the reason why we teach you permutations is so that when we go over combinations next, it makes a little bit more sense. Combinations, they look very similar to permutations. Notice again in the formula, you should notice that there are, again, these factorials, which means you, again, cannot repeat. Okay, so again, there is no repeating. Also, it's going to work the same way. You're going to start out with a total. Let's call that N. Instead of using P like we did for permutations, we'll use a C for combinations. And then you'll say how many you're going to choose out of the total N will come last, just like before, and we'll call that R. So what else is different? So far, everything else is the same as permutations. There's no repeating. You have a total. You have how many you're choosing. Here's the difference. And it's a big one. Is that with combinations, order does not matter. You're not putting things in an order where order matters. So this is the biggie. Order does not matter. The question is, what does that mean? Well, for example, our last problem of first, second, and third place, order does matter. I would rather win first place than third. So it has a different meaning if I win first place versus third place. As opposed to just being chosen to be in some kind of club. If I'm chosen to be in some kind of club, whether I'm chosen first or last, it doesn't matter. I'm a part of the club. That's when order does not matter. So in these problems, when they're all jumbled up in the homework, your key and how you're going to decide on whether or not you're going to use combinations or permutations in fundamental counting principle is whether or not order matters. So when you read a problem, the question should be, what happens if I jumble this up? Does it matter? Does the order matter? And what you'll notice is when we have the order doesn't matter, when you're doing the combinations, you'll do it the same way in your calculator. So if you wanted to do a 5C3, similar to what we did last time, you would type the 5 into your calculator first on the main screen. Then you'd go back, just like before, to your math button on your calculator. Then you would arrow to the right 1, 2, 3 times until you were at PRB for probability. And then you would go down and arrow all the way down to option number 3 where your C is. That is how you'd get that C in the middle. You still wouldn't be done though. You'd still have to enter in how many you're actually going to choose or use on your problem, which in this one would be 3. And your answer is way smaller than what we got for the same problem with permutations. It's just 10 ways. So what this would mean is that from a group of, let's go with the people example, 5 people, I'm choosing a club of 3 people. Doesn't matter in what order I choose people, so that's why the number is so small that I can choose 10 different, I can have 10 different ways of choosing 3 people to make up my club. Okay, so let's take a look at a couple examples. Baskin-Robbins offers 31 flavors of ice cream. One of their items is a bowl with 3 scoops of ice cream. Now, how many such bowls are possible? Assume that no 2 scoops are the same. Now, assuming no 2 scoops are the same, it's subtle, but what they're telling you is they're telling you that you're not repeating. And the reason why they're doing that is so that you know you can use something with the factorials, meaning you can use the permutations or the combinations, whichever one fits. On this problem, you're picking 3 scoops of ice cream. So the question is, does order matter? And so you need to think about it. So does order matter? Yes or no? Well, the example I always think of is, well, let me think of 3 flavors. So I'm going to choose for my bowl vanilla, strawberry, and chocolate. That's my bowl of ice cream. Now let's see what happens when I swap it all around and I give you a slightly different bowl, in my opinion. So you choose the same 3 flavors in a different order. Strawberry, vanilla, and chocolate. Are you getting anything different than what I ordered? You technically ordered something different, but is it anything different that you're getting? And the answer is no. You're still going to end up with a bowl of ice cream with the same 3 scoops. It doesn't matter what you ordered first and what you ordered last. You're still going to get the same thing I ordered. So, does order matter? No. If you mix everything around, you still end up with the same thing. So, the answer being no is how you know if order does not matter that you're going to use combinations. Now, I need to know how many total things I'm choosing from. Well, in this one, I've got 31 flavors to choose from. So that's my total that's going to come first. Now, of those 31 flavors, how many of those am I actually going to use? Well, I'm going to be choosing 3 scoops, so I'm going to choose 3 out of the 31 flavors. And again, they told me I couldn't repeat, so I'm all set, because combinations don't allow you to repeat anyways. So let's see, you'd go in your calculator, you'd do your 31 first, then you'd go over to your math key, and then you'd go over to your PROB or PRB option, go down to the 3rd option, the combinations. Be careful, you still have to tell it, even after you select it and press enter, that you want to choose 3 from the 31, and then you got to press your enter one last time to get the value for your combinations, which is 4,490. 95. And you're done. On this next problem, we're going to calculate